Okay, good morning. We'll get started here. Yeah, so thank you very much for joining us today. My name is Jocelyn Weber-Phipps, and I have the pleasure of being the Deputy Director for the Berkeley Center for Responsible Decentralized Intelligence. And I also had the opportunity to be the founding director of our Berkeley Accelerator. We want to thank you for joining us today, and also a large shout out to our sponsors today. That includes Archetype VC Group, WorldCoin, as well as a few others, Alio and Alethea AI. So thank you. Our longtime supporters are EduDAO and Ripple, who have been sponsors of our efforts at Berkeley for some time. We'd also like to thank our partners at IC3 here at Cornell Tech campus. Just to say a little bit about Berkeley, we're a large public university if you're not familiar with us. We do things at a very large scale at UC Berkeley with over 30,000 undergraduates and over 10,000 graduate students. So very large student body population to draw upon. And we're also ranked very highly in a number of disciplines, as you can see listed there. Today, we're really happy that you can join us. This is our second summit on decentralization and AI in the intersection of those two. Last year, we held this summit at Berkeley, and we had over 3,000 people register, over 1,000 people join us in person, and now 8,000 people have viewed the live stream content. So really a great turnout last year. And this year, we were really pleased to see that we had over 100 submissions for talk proposals and research papers. So thank you to all of the people that submitted for speaking today. And you'll hear from over 40 of those people today. I will want to turn it over now to Professor John Song to provide some opening remarks and to set the context for today. So thank you again for joining us.
Hi, everyone. Thanks a lot for being here. So first I wanted to just set the context for the summit today. So as we all know, it's been really exciting to see the explosive growth of AI and the deployment. However, at the same time, there are also many risks and open challenges for building a responsible AI. And so, for example, who controls AI? Should it be centralized or decentralized? And should we do open source versus closed source? And also, there are many challenges for building a trustworthy AI, including robustness, privacy, fairness, and many different aspects. And AI safety in general is also has many challenges, including how we can mitigate the misuse and abuse of AI and superintelligence and so on. So instead of building a platform, centric future of AI, ideally we want to enable a future of responsible AI with decentralization and democratization. That's really the focus of the summit today. And there are many open questions towards this vision. So, for example, first, can we build a full decentralized open source stack for AI machine learning? Including, for example, can we build a open source decentralized AI machine learning infrastructure for training and inference with provenance, integrity, and privacy guarantees? How can we enable more open source models and tooling, and enable building personalized AI with privacy and trustworthiness, and also enable decentralized and cooperative AI with proper incentives and social welfare, and finally enabling a democratic decentralized process for AI governance and alignment. To achieve this goal, there are many open challenges. For example, first, is this actually technically feasible? Is it actually possible to close a gap between open source and closed source models? Is it possible to scale decentralized training to large scale models? Is it possible to build autonomous, cooperative, and decentralized agents? And how to design proper incentives to maximize social benefits? And also, another open challenge is, can such an open source decentralized system lead to more misuse and abuse? Is this at odds with AI safety guarantees? And also, what are the different alternatives and possibilities that should be considered? So with this summit, we hope to spark conversations and cross-pollinate between diverse domains, including AI, machine learning, security and privacy, game theory, and economics, and decentralization technologies. So with that, as Justin mentioned, the summit has received over 100 submissions for talk proposals and research papers, and the summit has a really exciting program with a number of sessions that are designed to actually help answer many of the questions, at least start the exploration and discussion for many of the questions that I just mentioned. So the first session will be on open source AI, actually trying to discuss and explore many of the questions that I posed on the challenges for open source AI. And the session 2 and session 3 will be on foundations of decentralized AI, talking about different component technologies for enabling decentralized AI. And then we'll have research spotlights from PhD students. And then in the end, we'll talk about actually have real-world practitioners share their experience discussing decentralized AI in the field on data, infrastructure, and agents, and the future of decentralized AI and innovator showcase. And also, WorldCoin will be doing their demo of their orbs during lunch and the reception, and the summit will conclude with the reception and also the poster session. So that's the program for the summit today. I also wanted to briefly introduce the Berkeley Center on Responsible Decentralized Intelligence, RDI, which is the host for the summit. So this center is a campus-wide center that's multidisciplinary. It includes many different departments and schools on campus, including the Computer Science, School of Engineering, Haas Business School, and the Law School. And the center's key mission is to advance the science and technology of decentralization and decentralized intelligence to make it universally accessible and empowering a responsible digital economy. So it's really at the intersection of responsible innovation, decentralization, and AI and intelligence in general. And so the center has 3 key pillars: research, education, community, and entrepreneurship. The center, again, as I mentioned, is campus-wide, has many faculty across the campus, and I'm a co-director of the center. And the center focuses on interdisciplinary research in the areas that I mentioned. And besides faculty and students in the center also provides fellowships across campus for research fellows. And this year, the center has supported 15 frontier research fellows across campus. And the center has many different research threads, including in the area of decentralization and AI, and many other areas. So that's the first pillar of research. And the second pillar is education. So the center has initiated and led many MOOCs and cutting-edge courses on many cutting-edge topics, including, for example, zero-knowledge proofs in cryptography, and also various decentralization and AI topics, including Responsible AI and Decentralized Intelligence. And also in the spring, we had a class on Understanding Large Language Models, Foundations and Safety. And this fall, we'll be offering a class on LLM agents, which will also be open to the public. Many of our MOOCs actually have tens of thousands of students actually also participating online. And we've organized hackathons associated with some of these classes that had participation from teams from over 60 countries. So for this course, LLM agents, we also plan to have it available online and have also have a hackathon that have teams participating worldwide. So please stay tuned. And the third pillar for the center is entrepreneurship and community. And as Jocelyn mentioned, so she's actually the founding director for the Berkeley Accelerator, which is an accelerator on campus that actually help incubate and accelerate teams and projects. The accelerator was launched 5 years ago and has incubated over 110 teams, and which has together raised follow-on funding for over $650 million. And again, for more information, you can go to rdi.berkeley.edu to learn more about the center. And with that, we welcome everyone for the summit today. Great, thank you.
I'd like to welcome up our first speaker, Sasha Rush, who is an associate professor at Cornell Tech and a researcher with Hugging Face. So please join me in welcoming Sasha.
Hey everyone, I get to go first because I win the award for shortest travel. My office is right there, so I get to come here every day, which is beautiful. I am a researcher in natural language processing. I know nothing about decentralization, but I think natural language processing was hit pretty early with the open source bug. So I got interested in open source when I first started as a professor in about, 2015. I was really just into PyTorch. I thought it was incredible that suddenly a lot of applications I had worked on as a researcher were now available for anyone to use. So I spent the first couple of years just kind of building machine translation systems in an open source environment. In about 2019, all this stuff started blowing up. And then I saw a bunch of folks at Hugging Face building the Transformers library, which was kind of the first really widely used open source LLM system. And they were just doing it way better than me. And I got really excited about this idea that there was a kind of new emergent kind of ability of a kind of machine learning engineer who built open source tools and everyone could run them. And man, that's really kind of blown up. So it's been really interesting. Hugging Face has been a kind of center of collecting all the work that's been going on in these areas, kind of pulling everything together. And it's been really amazing to see. I'm not going to talk about open source stuff today, but we have a nice little panel where we can talk about it a little bit more and what's going on in that area. I thought it would be fun today to talk a little bit about some research we did last year, which was on the kind of questions of what happens when we start decentralizing embeddings. So this talk's called LLMs Inside Out. It's going to be a kind of a quick overview of some recent research work. I think this work is pretty cool. It also kind of conveys some intuition about language that I think not everyone has, and it kind of gives you a sense of how people in NLP think about language and neural networks. There's a full version of this talk on YouTube. I have a YouTube channel with a bunch of videos, so if you like this kind of stuff, I have about 20 videos or so you can go through. Let's see. Do I have the wrong clicker? How do I click? This one? This one, yeah? Beautiful. Okay, great. Cool. So this work is primarily led by my student, Jack Morris. Okay, so in this paper, we're going to be talking about text embeddings. Text embeddings, I think, are probably the most widely used application of a lot of large language models. People use them for everything from classification to retrieval, all sorts of applications of that form. Generally, the way it works is that you take some document, say a Wikipedia article, and you kind of mash it down into an embedding representation. This is just going to be a vector with a bunch of, say, floating point values. So a couple of years ago, there were about a trillion companies that started that kind of offered a service where they would take the embeddings for all your data. They would toss it into a large database. You'd be able to do very quick lookups on this data. We got pretty interested in a particular threat model for these sort of databases, which is we didn't really feel like anyone really had a good empirical sense of like what was actually in these representations. So for this paper, we're going to think about a pretty straightforward problem, which is imagine that a user got access, kind of raw access to an embedding database in a world where, say, some company represented as blue was going to take all their data, send it over to the database, and then send search queries that would let them look up information in that database. We're going to kind of imagine that the database doesn't have any of the original information. It just has these embeddings, and what could you do in that setting? So kind of here's a kind of version of this problem. So the bad actor gets access to your vector database. What do they know about the underlying system? Now, none of these kind of companies were claiming any kind of like hard security guarantee. But there was a lot of implication in kind of the marketing material that this information represented a kind of compressed version of what you originally had. So like you were throwing away a lot of information in order to do a kind of search problem in this sort of setting. So we were interested in the empirical question of like, what could you actually get back? So given that you have an embedding of some complex article, how close to the original can you actually get back in practice? So in the research literature, there were a couple papers that kind of looked at this. And there was a kind of sense that, well, you've thrown away a lot of information about word ordering. You've maybe lost something about proper nouns. A lot of stuff kind of goes away when you go to this form. Cool. So for the sake of time, I'll go through this quickly. We're going to kind of just try to do this problem as well as we can. Okay, so let's go a little bit more into the technical details. So the first thing you might think to do is to say, hey, let's just train a neural network that takes the embedding and tries to get out the text. This could be by simply putting the embedding as the first step of a standard language modeling, or it could be something a little bit more complicated where you train an encoder model that can then sort of try to get as much information out of that embedding and then send that to a decoder that tries to generate the text itself. The kind of assumption here is that we're going to have access to the embedding model, so we can actually create a lot of training data for this task, but we're not going to assume that we get to look inside the embedding model. So think about this as like you have access to the OpenAI API, you can make a lot of calls, get a lot of vectors, but you can't say, look at their weights or anything of that form. So when you start with something like this, you get what I showed earlier. You get out some text, you leak a bunch of important information, but you don't really get exactly what's there. And a lot of kind of important information gets changed. So I think this led us to believe that maybe there was some sort of compression going on and that we were losing a lot of the kind of original information when we just tried to learn a model to get out. In practice, though, the kind of key observation of this work is that we have a bit more information than just what I've shown previously. Since we're able to make API calls to the embedding service, we can check basically how close we were to obtaining the right answer. These models are deterministic. So if we take the generated output, send it back into the embedding model, we can actually check how far we were from the original vector. So we're going to assume we have this additional value, e hat, which is the re-embedded version of our generated text. If we have this sort of information, we can do an iterative process where we basically try to step closer and closer to the true embedding. So here at e hat 0, that's our original guess. We then take the text we produced, the original embedding, and our current embedding, send them back into the model and see if we can get closer. So we're going to kind of try to circle in on the text we'd like. So here's what the kind of final system looks like. We have basically two models, one that makes the original guess and one that tries to make a refined guess. The refined system gets to look at the re-embedded version of our output, as well as the last guess we had in the line. We're going to keep on running this system over and over again, hoping to get closer each time until we kind of zoom into our original text. Okay, so here's what it looks like mathematically. The main reason I put up this slide is to note that you can either kind of greedily keep on guessing or do something a bit smarter. What we're going to do in practice is run something that looks more like beam search, where we kind of search over different hypotheses to try to zoom in on the final output. Great. So we're going to compare our approach to a couple others in this setting. Skip through these. Cool. And so I'll just talk about some of the results. So two kind of ways we measure progress on this task. One is the amount of basically n-grams that we match. So pairs of words up to length 4. In NLP, that's called the blue score. We also have exact match, which is the percentage of times we fully reconstruct the original. Baseline systems for this task were at very kind of low accuracy. So every once in a while, you'd get a word or two out, but you're basically at 0% on real world data. With our system and one guess, we get to about 50 on blue score, but are still around only 1% in exact match recovery. The key takeaway is that if you're able to do this iterative process, you can basically solve this problem. So we get to about 92% exact match accuracy. And the 8% we don't get are very small things like commas or slight kind of variations on the original sentence. So this is up to about 32 tokens on a kind of known embedding model. But at this scale, I think this problem is basically solved. We also tried this at larger scale with 128 tokens using the OpenAI API. So we don't actually have access to this model. We can just make API calls. And here we're also able to do pretty well. We get up to about 55 blue score, and 8% of the time we have an exact recovery of the text. So it's not kind of perfect, but at 128 tokens, exact recovery at this rate is pretty good. Cool. So kind of the conclusion of this part of the talk is that, well, even though we kind of didn't have a security guarantee that embeddings were private, also practically they're basically not private. We think you should think about embeddings as basically being just a transformed version of the original text, as opposed to some sort of compressed version of the text itself. And in some sense, that shouldn't be that surprising. Text is highly compressible. These embeddings are pretty large relative to the size of the text we're generally putting into them. And so it's not crazy that even though they transform the information, they're not throwing a lot of the information away. Now, this is true even of bigger language models, and I'll talk a little bit more about them next. I do want to give a couple kind of qualitative views of how this problem worked. So one is that you really need to be able to do this kind of feedback approach to get this right. We found that with no feedback, these models basically tap out at a certain rate. So we're really learning kind of to walk around in embedding space. Let me go through these to save time. The other kind of thing we played around with was trying to defend against these sort of attacks. So one thing to note is that if you really do want to keep your embeddings relatively private, you can inject noise into embedding space directly to try to protect against this attack. So here we add Gaussian noise at different rates, and we find that our ability to reconstruct degrades significantly before our ability to do retrieval. So if you are trying to do some sort of just retrieval only based approach, you might be able to kind of defend against this just by adding in some noise in practice. Cool. So in the last couple of minutes, I'll talk a little bit about large language models. So large language models are even crazier in that they don't just store an embedding for every position. They don't just store one embedding for a document, they store an embedding for every position. So they're storing a significantly larger amount of information as they go. But there is one place in a model where you do get something that looks like an embedding, which is if you wanted to try to recover, say, the system prompt of a language model, the kind of hidden information that the language model provider puts before they generate your text, you do have access to the next token prediction of the model itself. And you can think about the probability over the next token prediction as being kind of like an embedding of all the text up until that point. So in a recent work, we looked at what you could do if you just have access to the next token prediction of these models. Let's just talk about what this problem looks like. So we're going to have a very long input to a large language model. And then we're going to be given the probability over the next word. And instead of generating forward in time, we're going to attempt to generate backwards in time. So we'd like to invert the prediction of the next word to try to recover all the words before that up until that point. Now, this seems pretty hard, but there's a lot of information exposed in that distribution itself. There are, say, 32,000 words in that distribution. So there's a lot of bits that we have access to at that time step. Cool. So just to give you a sense of how this works in practice, using llama chat and sequences of length 64, we find that this approach allows us to recover 23% of our prompts exactly. So this means we're fully able to reconstruct all the words before a given time step just by looking at the next word probability. So there's more details about this paper online. One fun part about this project was that several other research groups at around a similar time noticed a similar phenomena, and OpenAI actually changed their API to make it much harder to access this sort of information. And there's a really nice work from Google that shows you can recover a lot of information about the model itself just from this final layer. Cool. So if you're interested in this work, a lot of it is available online. The library is called Vectitext. And generally, the kind of high level is that you should think about what's in these embeddings, and you should kind of maybe not assume that there's too much compression going on inside large language models. Cool. Thank you very much.
I'd like to welcome up our next speaker, Mala Kumar, who is Director of Program Management for AI Safety at ML Columns. Please join me in welcoming Mala.
Use that mic.
Okay.
Yeah. Can everybody hear me, or should I use this one? Can you hear me? Yeah. Awesome. Great. All right, I'm going to do my best to keep this to 15 minutes, but apologies if I start to go over. Is this just the screen button? Great. Okay. Hi, everyone. I'm going to be talking to you today about building a global AI safety benchmark. So my name is Mala, and I'm the Director of Program Management of AI Safety at ML Commons. I've only been at the organization for a little over 2 months, and prior to that, I was the Director of Tech for Social Good at the Microsoft-owned company GitHub. I've also spent more than 10 years working at the United Nations in 4 continents, building and designing and deploying tech tools all over the world. A lot of my time has been with the World Health Organization, UNICEF, and the World Food Program. And like Sasha, although I'm not quite as local, I am also based here in New York. If you're not familiar with ML Commons, our mission is basically to make better AI for everyone. It's a global engineering consortium, business consortium, bunch of partnerships going on that really focus on building benchmarks and public data sets. ML Commons was established in 2020, mostly focused on machine learning performance for hardware in aviation, automotive, and other industries, and recently branched out into AI safety. So earlier this year in April, we created what we call the proof of concept AI safety benchmark, and we're now working towards the production quality of our benchmark, which should come out in October or November of this year. The idea is that we get on a continuous cycle. So the idea is we're going to hopefully release more benchmarks next year and the years beyond. And unlike a lot of AI safety, initiatives out there, again, our focus is really on the engineering side, but we also combine those rigorous methods with high trust and open community-driven approaches. Our work would not be possible without all of the working group contributors. Many of you probably work at some of these organizations and companies, so thank you very much for your support. Even if you didn't know about it, we deeply thank you. All right, so before I talk about what a global AI safety benchmark is, I actually want to talk about this word global. I think this probably resonates with a lot of people in the room who are not native English speakers, who are coming from other countries, who are trying to do things in multiple languages. As you've probably noticed, if you bounced around different sectors, this term global is not consistent. It doesn't mean the same thing across the world, ironically. And so I want to spend some time on that. And one of the ways that I like to talk about this is quite literally the segmentation of what global means. If you've ever worked at a tech company, you've probably seen this acronym on the left called EMEA, which stands for all of Europe, all of the Middle East, and all of Africa. But coming from the UN system, it was interesting to me because we would divide this out into probably 7+ different segmentations, including the Middle East and North Africa, 3 other segmentations across sub-Saharan Africa, and 3 segmentations in Europe. And then, of course, the tapestries of what comprise global ecosystems and global tech is quite diverse. You've got everything from Silicon Valley. A lot of you probably represented in academia and government. We have international institutions. I'm sure many of you have worked in open source communities. And then I've spent more time than I can count in local African health centers. And I would even argue that itself is its own global ecosystem because they have different data protocols, collection methods, bespoke solutions, businesses, government centers, everything that kind of comprise what it means to collect data and provide services for African context. So can ML Commons address all of these concerns? Of course not, but I do think we're off to a great start. Trigger warning, we do have some brief mentions of suicide, self-harm, and sexually explicit content in our taxonomy. So, please, of course, feel free to leave if that's triggering for you. But the scope of our AI safety benchmark. So I'm sure this room is quite familiar with the idea of benchmarks, but benchmarks have been around for decades to really drive progress and help people make decisions about complex product safety. A really good example of this, of course, is the moving rating system in the United States, where you take a 2-hour-long movie and all of the content therein, but there's an organization that's tasked with coming up with one top-level score to tell parents, guardians, whoever, if this content is safe for their children. And then, of course, there's things like drug labeling in the pharmaceutical industry, where you take the hundreds of different ingredients or components or toolings or patents that go into creating one drug, and then you boil that down into drug facts or warnings or directions on how to safely consume that. And so the theory of change with AI safety benchmarks that ML Commons has is it can drive progress at the policy and regulator level by using that to create requirements and benchmarks, with AI vendors to create benchmarks to guide research and development and conform customers, and then, of course, with integrators and deployers to use benchmarks to inform purchasing and establish compliance. So the scope of our actual safety benchmark that's coming up, we have 12 hazard categories, including violent crimes, privacy, sexual content, and the list that you see here. We also have 3 persona or prompt types, one of which we designate as quote unquote normal or safe, and then the other 2 that we call unsafe, whether it's split between skilled militias and unskilled militias. Then we also have 4 languages and localizations which combine form our locales. So we have English localized to the United States, French localized to France, Simplified Chinese localized to China, and Hindi localized to India. And I'll talk about this section in more detail later. So we have a lot of ways that we could actually be testing these hazards. Some of our systems under test or sets could include fine-tuned models with these hazard categories. The idea being that we're basically looking for the model to not respond, or to decline to respond, or to refuse to respond, or to generate a response. And then also basic use cases or generic chatbots along these 4 hazard categories. The idea being that they would come back with a relevant response, but of course it's out of our scope to really evaluate whether that response is accurate, but what we're looking at is whether it's quote unquote safe or unsafe. Now, as my colleagues stress to me all the time, and of course I agree, models and applications are deployed globally, and so we do have the need to create a standard core taxonomy. But of course, AI safety is so complex and context-driven that one of the things we're looking at is how to build additional layers, whether it's a regional layer or a functional and a domain layer. And so we're hoping that all of these things combined, all of the considerations we have, really will speak to the priorities of the diverse set of AI safety stakeholders, whether it's industry looking at keeping customers and users safe, or civil society trying to use AI to advance human development. I can talk to you all day about that. Or governments, whether they're trying to advance national or economic interests and then scale their constituents. So a wide range of things that people are really concerned about. And of course, these are non-exhaustive and many of these overlap. All right, so realities of building a global AI safety benchmark. Now, I'm sure everybody in this room, if you've ever worked in open source, you've definitely seen this cartoon before. It's been used to describe many things in many different ways. And for me, it really exemplifies the fact that the internet is not one coherent entity. If you've ever built any kind of tech tool and explained it to somebody who doesn't work in tech, you probably get a lot of shock. Like, I think CrowdStrike was a very good example. Jocelyn and I were just talking about this earlier. People are shocked that the internet doesn't work the way that it's supposed to, right? But those of us who actually build tools know that the internet looks something like this. I mean, it's basically a bunch of things stuck together, plugged in together. Whether you deploy it in one country or one language or whatever else will determine kind of the experience you have and the way that you can go about building something. And so if you're like me and you spent your entire career building complex tech solutions around the world, one thing you learn is that the internet was built for English. I have a lot of examples of this throughout my career, but one of my favorites was when I was in the West African country of Mali back in 2017. So this was my designer stage of my career. And it was my job to build an app to help youth engage better with local politics. And so I asked one of the youth leaders why the pervasive tool of all tools, WhatsApp, had become so popular in Mali. And I'll paraphrase because this is in French, but she said to me in the most like teenager annoyed voice, duh, because it's easy. Right? It's not that the average Malayan citizen is really concerned about their cybersecurity footprint. Some surely are, but that's not the reason why WhatsApp became so popular. It's because it's really hard to type in Bambara, which is one of the languages they speak and use in written form, on an English or French keyboard. And so encrypted voice notes became super popular on WhatsApp for that reason, really not for many other reasons. And so one of the things that we hear a lot in AI and ML is this idea of low resource languages, which for me, coming from the tech for social good UN side of things, is funny, honestly, because we're talking about languages that often have 500 million to 1 billion native speakers. They have thousands of years of written text, advanced grammar structures and sentence structures. A lot of them have native alphabets. But the problem is that we don't have a ton of machine readable data that we can responsibly access and use. And so when we think about things like how do we look at translation versus customization, this is something that we're contending with a lot at ML Commons. So one thing that you can hear quite a lot in the American far right of politics is this insult, she's such a snowflake. Try to translate that to Hindi. What does that mean, right? Who cares? Like a native Hindi speaker will look at that and be like, we don't have snow for one thing, but also like, what's a snowflake? So when you bring all of these things together, you have to think about like, when we build a global AI safety benchmark across languages, how can we standardize things enough so that the different languages are comparable? But then how can we also customize things across contexts enough so that it's useful? And especially knowing that English will be better represented than basically all other languages and large language models. Shameless plug, although this is relevant. Separate to my tech world, I am a novelist, so my second novel is coming out in October. And unlike the internet, it is a beautiful and coherent thing. It's also 87,000 words, and it's probably about this thick. But then all the complicated math that my colleagues at ML Commons have told me is that in order to get full coverage of our hazard categories, our personas, and our languages, we need between 150,000 to 200,000 prompts. So if we take 150,000, the lower end of that, and multiply that by an average of 20 words per prompt, we get 3 million words. So you compare 3 million to my beautiful, coherent 87,000 word book, it's a lot of words. You convert that into equivalent tokens, that's a lot of energy required in order to run these kinds of tests. And so it's important that we get this right and we don't do it in a way that's wasteful. We don't have all the solutions at ML Commons, but we are working on a couple of, I think, really good ones. The first one is really just to create a truly global pipeline of prompt suppliers. So in addition to going to our direct contacts, one of the things that I launched, right when I got to ML Commons was a global expression of interest. We got a lot of interest, thankfully. That was the whole point. Many submissions representing, I think, organizations and companies in 10 plus countries and 20 plus languages. And so the idea is that we can go directly to these suppliers and get things that are context driven and actually make sense for what we're trying to build. And the other great thing about that is it allows us to experiment in parallel to our core scope. So some of the actual proposals we got through our expression of interest are things like deepening our coverage with specialized advice in core languages or looking at demographic bias in our core languages. We also have proposals to expand coverage, whether it's to add sample prompts in other languages, explore demographic bias in those other languages. And then we also have several proposals about how to create prompt generation methodologies based on behavior. Clinical care is a really interesting one we got, and then several based on activists. So them working with populations that actually deal with hate speech on a daily basis in a local language to create these prompts. One of the things that I'm really excited about is that we also have a lot of means to engage with globally diverse efforts. Earlier this year, ML Commons signed a memorandum of understanding with the Singaporean foundation AI Verify. We're also in talks with a really interesting organization called Masakane, which is an African language NLP community. And then, of course, as many of you might be aware, there are a lot of government initiatives to build large language models in languages for the citizens of their countries. So the Indian government, for example, has initiatives for Tamil, Kannada, and Telugu large language models. All right, so if any of this piques your interest, there's many ways to get involved. We have 8 different work streams in our AI safety working group. Each of these have a dedicated leader. They also have dedicated community calls. If you're interested in joining, I recommend you take a picture of the slide. You can also reach out to us at joinaisafety@mlcommons.org. We have weekly community calls that are open to basically the entire public. So I'll give a minute for everybody to take a picture. And then once you do get involved, we do have ways for you to volunteer on specific things. So thank you for your time.
Next, I'd like to welcome up Dean Wampler, who's at IBM Research, and he is head of technology representing IBM at the AI Alliance. Welcome, Dean.
Thank you. Okay, thanks for having me. This is really exciting because I don't know a lot about decentralization and know a lot more about AI, so I'm looking forward to really learning a lot today. The pictures are all like generated by Adobe's Firefly AI system based on pictures I take. I've always put my own pictures in slideware, but AI has made photography obsolete, right? So can't do that anymore. So I decided to just let Adobe do it for me. You can get these slides and some of my other talks at this QR code, and I'll have that at the end as well. deanwampler.com/talks will also get you there. Wrong button, there we go. What I'll talk about a little bit is whether or not AI should be open, some of the reasons why we want to do this, and pros and cons. And because of time, I'll only talk briefly about this issue of alignment as an issue that is something we have to solve if we're going to get widespread adoption of AI, and maybe speculate a little bit about decentralization as one of the tools to address some of the issues of alignment. I'll define, of course, what alignment's about. All right, so should AI be open or closed? Well, I think the general trend in industry for the last couple of decades has been that a lot of stuff starts out proprietary, like languages, operating systems. It's kind of funny to believe that we actually used to pay for programming languages, but I've been around long enough that I remember doing that. And even like web tech, when I first started in the internet era back in the 90s, we used commercial tools. We didn't rely on that Apache stuff, because that just wasn't reliable in quotes. But of course, most things become commoditized and then they become open typically. And the same thing I think is going to happen here, to cut to the chase. I won't explain this diagram, but basically what it's showing on the top is sort of a typical developer workflow where I start with source code of some kind, often now in the open, and hence the term open source. And then from there, I go through a process of building artifacts that are binary that other people can use and that are distributed in some way. But we've actually changed that picture a lot with AI because we've added this thing I've highlighted in pink, which is the data sets, which are actually the most important part of the models now. And it's not just the source code. So when we talk about, I mean, I hate to use the word open source when we're talking about AI because it's almost like that's not the point. It's just openness, period. It's not just source, it's actually data as well. And so that's one of the big questions. But the world we're living in right now is that the thing that's circled in red is what's actually often open, which is this binary artifact, effectively binary, that is the model. And you may have a description of how they built it, what they did to collect data sets, what maybe, in broad terms, what data sets they used and how they processed them. But it's in no sense possible for you to go back and yourself create like the Llama models from Meta or even IBM's Granite models and so forth, even if you had the compute resources to do it, because those things are not open to you at this time. But it seems like most people don't care. I mean, right now, everyone is just trying to figure out if this stuff works. They're often in proof of concept phase, sometimes going to deployments. But eventually, I think we'll get to the point where people will care about what's on the left, and then we'll start to see things open up more than they have so far. And I'll talk about that briefly in a second. All right, well, so why does openness matter? Well, this is a nice capsule summary, this first sentence that I'll just read. I normally won't read the slides, but the benefits of openness can be summarized as autonomy, that people can kind of do what they want with it. Transparency, an important aspect of that is security. One of the big arguments that was used against open source software in the early days was, how can this be secure? If everybody can see the source code, then everybody can find the vulnerabilities. It turned out it actually worked because more people were wearing white hats and looking for problems and fixing them than were looking for vulnerabilities to exploit. And so this is a benefit of openness. Also, frictionless reuse if it's unconstrained, and then the ability to collaborate together to bring lots of people with interesting ideas and time on their hands in one way or another to actually work on stuff. And as I said, a number of things have gone from open or closed to open over time. Even though, like in this case, the operating systems, none of those have gone away, although Unix is not used much anymore. But we definitely have open source options. Really, the key issue, though, right, as far as AI goes, is do we actually want something that seems to be so pivotal to our future to be controlled by a relatively small number of well-capitalized entities? Or do we want it as open as possible for people to do the things that are highlighted in the first sentence, collaborate, use in some way, improve together, and so forth? And that's kind of why the AI Alliance was put together, mostly from IBM and Meta as the founding members, along with 50 other organizations. You obviously can't read this diagram, but it's showing that there are universities, startups, various enterprises around the world. And this is actually slightly out of date. This diagram was done in February, but there's now 110 members, trying to bring a diversity of opinion, a diversity of concerns, a diversity of expertise together to make sure things are as open as possible, but still used in as reasonable safety constraints. And then lastly, on the Alliance, the 6 areas that we've been working on are things like education. How do we help people, whether they're developers or business users or consumers, how do they use it effectively and understand what it's about? Actual research in trust and safety, various tools for building stuff. Hardware portability is, how do we make sure that we can use diverse hardware options and not just have to buy NVIDIA GPUs? Quite frankly, that's what that's about. And also broad availability of open models and data sets. One of the things I think is fun about number 5 is that there's a lot of interesting stuff happening in science, like models for molecular discovery. Time series models turns out to be a pretty hot but kind of boring topic for a lot of people when we all talk about language models. But there's quite a diversity of stuff we want to make sure is covered. And then policy and regulations, like responding to various government initiatives to hopefully get a good diversity of opinion there. I'm glad that Mala talked about ML Commons before. Trust and Safety is actually the group that I co-lead, and they are a member of that group, and we collaborate in some ways there, and have really been excited to participate in that effort of building this AI safety initiative that they're working on. Okay, let me just briefly talk then about alignment, what that means, and maybe a little bit about how decentralization can help. This is actually a real photo, but there are bits added to it. I'll let you guess what I added with AI. So what is alignment? Well, it's really, actually, this is a word that's defined a lot of different ways. The way I like to define it is, it's really assuring that the models or the system around the models are actually doing what you want. Are the results actually useful to you? If you ask for a recipe for a cake, you get a dissertation on the history of cakes, or you get a cake recipe. That's not a safety issue, but it's obviously a utility issue. But also, is it secure? We've already heard today about ways you could potentially hack systems. Is it free of bias, objectionable speech, and all that? You know, this is the kind of stuff ML Commons has been doing a lot of work on lately. And then this issue of hallucinations. Hallucinations is a fascinating topic. And just briefly, if you are actually using, say, OpenAI to come up with ideas for a movie script, you actually want hallucinations. You know, you want it to invent stuff, right? And you probably don't want it to give you copyright information. But if you're trying to like diagnose X-rays or help a customer with their flight reservations with a chatbot, hallucinations are a bad thing. So this is actually a great example for me of something that everyone thinks of as bad, but it actually really depends on the context. But in general, this is the hardest problem we're dealing with right now. I've certainly talked to a lot of people anecdotally about projects they're doing, and typically they stop at the proof of concept phase because for some reason they cannot trust the results enough that they want to deploy this system. But actually, I think there's a solution to that problem I'll get to in a second. But first, let's just talk about decentralization. I'm not the expert here, so a lot of these 2 points are probably very naive for some of you, but in case they aren't for all of you. Federated learning is really kind of cool and interesting. We've been using it for a long time to recognize our fingerprints and our faces on phones, where a model is sent down to your device, trained locally on your private data that never goes up to the cloud, and then model updates are shared and merged together. It's a really cool idea. I think this is actually a way that will eventually do a lot of model training. And the reason is that it feels like we're in this stage now of just massive compute, massive model generation. But at the same time, one of the interesting trends over the last year or so has been extremely improved performance of small models. And models that are, you know, maybe start small, aren't so great for your problem when they're small, but they can actually be tuned to be better for your problem. So there's a lot of ways in which if we can distribute compute, and even if it's inefficient, if we have the time to wait for it to finish, then I think we can actually get a lot done with the distributed techniques like federated learning and differential privacy. The thing about distributed ledgers, I think, is really interesting for a problem that people are kind of ignoring right now, as I said early on, which is, I don't really know what's inside this model. I don't know what was done to build it, what data sets. Am I going to get sued if it starts spitting out New York Times copy verbatim, for example, which of course has happened. But I think over time, especially organizations that are fairly highly visible, well capitalized, like financial institutions, are going to be very particular about what they deploy and know exactly where that model came from. And techniques like unhackable distributed ledgers are a great way to both do things like distributed training, data aggregation and processing, and then have a really good record of exactly what happened and ensure that it hasn't been hacked in some way. Okay, so I think, again, well, this is kind of making the same point, so I'll skip it. The problem right now, getting back to that problem of alignment, is everyone is talking about basically automation, like a chatbot that can just take your order at McDonald's without failure, or handle that reservation request without a human intervention. But what AI is actually really good at right now is basically augmentation, making you more productive. And that's where I think we need to get to, is focusing on augmentation today, and then think about automation down the road as we solve a lot of these alignment problems. So basically keeping humans in the loop, using the technologies to translate between languages. One of my favorite examples of this is text to SQL. how many people, you know, that you've worked with that aren't technical have wanted to like look at their databases and understand what people are up to, but they didn't really know how to write SQL queries beyond maybe something very trivial. Well, if they can just say what they want and we generate SQL and run the query, we've actually, you know, accelerated their productivity. And also the other thing that's happening in the whole agent model is that we're combining language models with reasoning systems, planning systems to make stuff that is rigorously precise where it needs to be while using language models to bridge these tools. And a good example of augmentation was this was in the New York Times a few weeks ago. Basically, a massive copper lode was discovered in Zambia by using AI models to do very subtle analysis of existing data from old mines and so forth, basically accelerating productivity that might have taken humans a lot of time to figure out without this tool. So that's basically all I have. Thanks.
Next, I'd like to welcome up our panel, our first panel of the day on open source versus closed source. So the three speakers that we just had join us will be joining that panel, and the panel will be moderated by Sam Bronner of A16Z Crypto. So please join me in welcoming Sam and his panelists.
How's it going? I was going to introduce you all, and I did not realize you'd give a 15-minute talk each. So, but just in short, for those who did not get to see, I'm going to orient myself a little bit more this way because more people are on that side of the room. Dean is the head of technology of the AI Alliance. I think everyone here just saw him speak. That was wonderful. Thank you. Mala, again, a director at the ML Commons, doing work to make AI sort of more available for everyone in many different contexts. And Sasha is a researcher who works just over here, but gave some pretty striking examples of how you can reconstruct training text and embeddings from especially smaller models, but also possibly for larger models. This talk is about how open AI can win. I think just based on Dean's talk, everyone has at least a little bit of a feel for what open AI can mean. But I do want to just summarize the top because this deserves to sort of get that headline. Dean, could you just share both how you think about open versus closed AI, but then just a quick summary on what parts of the open source AI process needs to be open sourced for it to be open?
Sure. I think it's interesting just to look at general software where we still have a lot of proprietary software. I mentioned Adobe, for example, their apps. People like an integrated experience, even if the stuff underneath is open source. And I think that's what'll happen here. A lot of the stuff that isn't open will gradually become open as it becomes more commodity. And also, as we become more concerned about that kind of ability to inspect and adapt things. But ultimately, it's an economic choice. If you really are comfortable with ChatGPT, then by all means, you should use it. If you really need to know what's going on in the models and in the data sets, then you'll probably wait and use open source, I think.
That's interesting. I actually wonder if not everyone agrees with that. I mean, Sasha, I'm curious for your perspective as a researcher, why may you prefer open source AI or why may you prefer closed source AI?
Oh, in research, it seems like we just wanted everything to be open source. I mean, I don't think anyone would prefer closed source.
Well, what are the capabilities that you're getting out of open source AI that are important to you? Like what parts of the stack need to be open in order for you to feel like you have the flexibility to move the research sphere forward?
I feel like we're ants and there's like this like massive battle going on. And for researchers, we're interested in like knowledge. And so we'll use proprietary things if we have to, but this is being fought in, I don't know, spheres that are like infinitely above our heads. I mean, we'll take whatever is available, but of course we want it to be open.
Okay, I think that makes sense. But I guess, in the work that you're doing, it seems like you want the weights to be open. You want the training data to be open. Which parts of this are you finding closed source AI is most keeping behind doors and you're eager to have be out in the sphere?
I don't know. I want to break in OpenAI and play with GPT-5. I mean, like, I'm so fascinated by what it could plausibly be. But I mean, like, I don't know. I understand that like billions of dollars are being thrown around here. So if Mark Zuckerberg wants to toss us his morsels, like, awesome. Like, it sounds great. Yeah.
I think we are all grateful for Meta, at least today, until their incentives change. But well, I'll ask the same to you. I mean, I'm curious how you think about what is making open source AI so applicable to your work and why it's important.
Yeah, I mean, I think there's a couple things. So a lot of the lessons, like Dean was saying, can be drawn from the open source software community. I think one of the points that I don't really hear talked about at all is just the cost of labor, which is something that we have drawn from open source. So if you look at proprietary licenses for any application, doesn't matter if it's AI based or not, in some cases, it's quite literally just more expensive to get a proprietary license to do something rather than build something, locally. And so if you look at the labor cost of open source software, I think that'll also become a factor when it comes to open AI. So like a lot of the government initiatives I mentioned about building large language models for, languages that are underrepresented with machine available data, it could just be that it's cheaper for people to build those large language models rather than wait for proprietary license that they can get an API from OpenAI or whichever company. I think the second thing that is not talked about as much as it probably should is really just, again, like the usability aspect of it. So one of the things I did at GitHub was I launched the first open source program office in the UN system, and that was with the World Health Organization. And the reason we did that wasn't just, for our own edification, hey, this is a cool idea. It's because it was the height of COVID. And WHO needed to work with basically every single, national health center, every single public health center in the world very quickly. And so the fastest way for us to do that, quite literally, was just to build out the open source software capacity, because it turned out a lot of that data could be shared on GitHub. And so rather than creating a memorandum of understanding or some kind of contractual agreement among all of these different organizations, that problem, which is something we heard a lot in the tech industry 10 years ago, solving problems, that problem was solved through open source. And right now, I think a lot of people probably in this room even are still struggling with, okay, it's open, but like, what problem does that really solve? Like, it's so complicated to use some of these things that even if I open source the model weights, I can't do anything with that on my computer. I need to hire a team just to understand what the open source model weights even mean, right? How is that applicable to what I'm trying to build? So I think we're not yet even close to solving that problem. And if we do, then I think we'll have a more robust debate around open source versus closed source AI.
There's a lot there. There's actually a few things in that I'm going to want to come back throughout the day. But the first is just sort of, we are seeing open source models come from a couple of places. I think the two most obvious, to put it into broad camps, would be a grassroots effort, and then large companies that seem to have some incentive around creating an open model. Both seem relevant to how open source AI can win. I'll put this up to all three of you, but does anyone have a perspective on how we're going to align the grassroots effort with the larger enterprises that are doing open source AI efforts?
Maybe I'll start. Because it's possible to take generic models and tune them for your particular needs, I think it'll probably start with, we'll just use Llama or one of those open models, and we'll work together to tune it for being good at legal document processing or something like that. But eventually, I think we'll figure out ways to, actually an example I thought of earlier today was, you all remember SETI at home? This is like back in the 80s and 90s when it would use like spare cycles in your PCs to process astronomical data to look for, aliens. I think we'll probably get to something like that where people can just leave their computers on the net running and it'll be doing some training just a little bit at a time. And if you don't care about getting it done in 2 weeks, so you can wait a year, then great, you can get a really good model in that time frame.
I just want to flag, like, for the decentralized people in the room, that kind of federated learning seems like it would fit in quite well with the rest of the pieces of the day. I'm very excited about it. Anyway.
Yeah, I mean, I think a lot of it, again, comes from what's happening in the open source software community writ large. I mean, we went from this grassroots level 50 years ago to being the pervasive model, so to speak, to enterprise everything. I mean, everything became about selling business to business, B2B instead of B2C. So if you look at the top contributors of open source, it's also something I was just speaking about with Jocelyn. The top contributors in terms of the number of contributors, the lines of code, the number of products, everything, and any metric that you look at, the top contributors of open source software, regardless of AI, is large enterprises. And so I think that's mirroring what we're seeing now, is that in order to do anything with AI, it's just so expensive. I mean, I showed out 3 million words for our one AI safety benchmark. Right. So who can process that many tokens and like out of pocket? You know, I can't.
Yeah. I guess that is to say, like, we do ultimately just have to have alignment between enterprise and sort of the grassroots effort.
I think, and the cost just needs to come down, and also the use cases of what we can build with kind of that grassroots level. We're not at the point yet where I would ever propose an AI solution to do something on like for my personal daily use. It's got to be something that I can then monetize or sell to other people, right?
Yeah, I think another thing you framed really well, Mala, is just sort of about the usability of these large models, both in terms of just can we fit all of this on one computer, but I think it's worth speaking to, you know, I need a key value store, I may need a RAG system. The usability of open source models today is at least a little bit less than that of some of the enterprise models, some of the paid closed source models. How do you think that will resolve that in the coming years? Are there any initiatives that you're particularly watching that you think will make open source models more effective?
Yeah, I mean, in my world, this is something that I'm pushing the UN to get to, but it's slow moving. I think there are some specific use cases. So one of the things that we've talked a lot about at ML Commons is how can we properly integrate human rights? Because human rights is something that is very complicated, but there are things like the Universal Declaration of Human Rights that have been signed by almost every country in the world, and that is not simple. That is a very difficult thing to do. So if we were, for example, to build some kind of RAG system plus have open source model weights where we could actually fine tune something so that it is appropriate for a human rights context, like it would actually differentiate between general hate speech and something that's genocidal in nature, that's something that we could definitely employ. But again, it's so complicated and so difficult to implement that now. And how do we do that in a way that, again, like works across contexts, languages, all of those like really difficult problems. So if we can solve for some of those kind of like ancillary things, which I think is what Dean talks a lot about in his alignment work, I think we can get to the point where we have specific use cases, at least for social good and you know human development, where it makes sense to have open source versus proprietary.
And I think that brings up a sort of another related issue, which is what I hear from maybe AI doomers, but also AI regulators, some idea that, and Sasha, just prepare you, I'm going to ask you first for sort of a technical thought on this. People worry, can you embed a virus in an open model? Could you maybe embed sort of subtly malicious ideas into an open model that proliferate? I'm curious how you think in your work about checking open models for those kinds of malicious intent, or if you think it'll be solved through more of a social good, social perspective than a technical perspective.
So let's see. I'm a researcher. I really like open source. It drives what I do and what's interesting. I don't get to talk to a crypto audience that much, so I do want to kind of like take a second to just say like, I'm like mildly worried that AI will say harmful things. I am really worried about all sorts of more local issues. And in particular, like, I don't really buy that, like, I don't even know how to say this. I don't like the political stance that crypto is taking in order to argue for open source. And I don't like that those two things are conflated. Like, I mean, A16Z has like, I don't know, look up their founders, like look up what they're donating to, look up what they're doing. Like, I just don't feel comfortable with those two things being connected in this way. And like, in particular, this implication that we need to have like kind of like a libertarian government in the United States to protect against like the usability of open source, like that rubs me the wrong way. And I just want to take this chance to say that because I'll feel bad if I don't.
I agree.
Thanks for sharing. Would you want to talk about how you think sort of technical work can be used to constrain models in a way that gives them more alignment or resolves any security issues?
Yeah, we should work on these problems. We should try to make things be open source. They're hard problems, but they're not real problems. I mean, they're not like tomorrow problems.
As in, you think it's like, I guess that's sort of an optimistic view. Like, you think it's relatively likely that open source AI can be used for good in the near term, and it's unlikely we'll have malicious attacks through that vector.
Yes.
Cool. That's great. I want to ask another question, sort of about maybe sort of what developer-centric things, maybe people in this room are a technical audience, what people can do themselves to support open source AI initiatives, and what the projects you're seeing that you think need the most urgent work in order to make them competitive with closed source projects. Maybe Dean, you've seen some of these things through your work with Meta.
Yeah, actually, I think it brings up a good point that we obsess about models, but it's actually the whole ecosystem of tools, because models have their strengths and weaknesses. So even if you don't have like GPUs to actually train models, you can do things like contribute to this ML Commons initiative, which doesn't require quite the same resources. So I think there's a whole lot of ways that we can think about blockers to adoption and tools that help us fix this, things that are emerging already, and then find ways to contribute there. And that may be how the community really works together, even if we tend to rely on a few models that are developed by really big companies for the time being.
I guess I'd love to get more specific. Like, what are there things in particular that you think are out there? Is that just, we need people integrating it in various languages? We need better SDKs. Are you looking for maybe like a Supabase style equivalent to Firebase? These sort of alternatives that allow AI models to be hosted more readily, or everyone should go find their own pet project and go after it that way.
I think two things I would recommend looking into. One is, how can you contribute to safety criteria, like writing prompts? They put out a call for help for writing prompts. Anybody can write a prompt, because it's once you learn what is useful. The other thing would be things like lots of interesting tools are emerging for running models on laptops, which makes them a lot more accessible to people, and also even just for development purposes. So those are two areas I would look for ways to contribute if you're looking.
Okay. And I want to put the same question to you, Ma. I feel like you're touching so many initiatives that, especially, this is a very English-speaking audience, it's a very local audience. Maybe there's some projects that you want to speak to that people can look up to, donate to, or maybe contribute to.
ML Commons. End of list. No, of course. I can say on the AI safety side, one of the issues that we're constantly running into is language support for evaluators. So if you have ideas, then please feel free to reach out. We have large language models in far more languages than we have evaluators for those models. Another way, kind of what Dean was saying, is community-based initiatives. I mean, that's really how open source software thrived, was a lot of the community-based things. But I think with a lot of ML AI stuff, there's a dearth of communities out there, which is one of the reasons why ML Commons has thrived. And then, unfortunately, it's all the boring stuff. It's the documentation, it's the education can be interesting, but the documentation, nobody likes that part. Those kind of things really, really help a lot of different people. So focusing on things that maybe people don't necessarily love, but are really useful for kind of, promulgating the knowledge that we need. And then another call that I'll make, also want to echo Sasha's point earlier, but I think one distinction that I never hear, and this is something that I've been developing over the past couple of months, is the distinction between like the trust and safety, AI safety world, which is about mitigating human rights violations and mitigating ethical and moral harms, versus the advancement of human development and human rights. And those are two different things. I won't get into it because it's out of scope for this call, but a lot of what people care about is making sure that people have access to good healthcare, or to education, or to food security. Those are the things that really motivate a lot of people, and there hasn't been a ton of work in the intersection of anything AI, ML with that, and that's for a lot of reasons, part of which I think is because we haven't quite nailed down the alignment issues and the trust and safety side. So if you have a fundamentally bad, quote unquote, model or tool or application that is hallucinating all the time, or potentially spitting out unsafe content, then you probably can't go and use that to advance human rights, right? So there's a lot of issues that need to be addressed before we get there. But I do think in the coming years, once more civil society and international organizations do more with AI, there'll be a lot more ways to contribute.
Yeah. No, I think that's likely to be true. And I think, in my own life, I've just seen how much easier it's been to get to use technology for whatever purpose you want. And I'm quite hopeful that the open source models that I'm already enjoying playing with will be usable by people to make their lives better on a daily basis. Sasha, I'll ask the question to you, and then I think we're out of time, which is just what's the tool or sort of open source project that you're most excited about right now? Hopefully something that you've touched or can recommend to the audience to check out.
I think the project I'm most excited about is LLMs. I think they've done an amazing job of doing evaluation, kind of keeping track of everything, putting out tools that people use. Again, this is more on the research side of things, but I think as a community, that's been really impressive work, and I know you guys have worked with them.
Cool. Well, thank you all for the time. Again, appreciate it. Thank you to the panelists, and hope you enjoyed. That's great, guys. Thank you so much.
Thank you. Sure.
All right, we're going to start session 2 of the programming for this morning, Foundations of Decentralized AI, part 1. So I'd like to welcome up our keynote for this morning, Modi Young, who is a research scientist at Google. Please join me in welcoming Modi.
So touching points of cryptography and AI. And, it's my background in mathematics. So two curvatures can touch in various ways. So, previously when I gave this talk, the first question there came up. And people say, crypto is a very precise, very formalized, very theory-oriented area. I'm talking about all cryptography, not just cryptocurrency. And you have proofs, and you understand the security claims and so on. And AI is much more practice-oriented, much more experimental. We don't even understand why it works. We know sometimes it works, but we don't understand. So what these things have in common. So the goal of this presentation, and this will be a short version of the presentation, is to argue that the two fields are not a match made in heaven, but it's not hell either to try to combine them or find areas of intersections so AI is starting to penetrate the field of cryptography. Last year, the major conference, Crypto 23, there was an invited talk by Scott Aronson, who gave a talk about some intersection of AI and cryptography. And the issue is that AI is in a process of being developed, so it can be solving or helping humans to solve very meaningful problems, and safety and issues like safety and so on come into play, and cryptography is a tool there. And on the other hand, models in AI need to be protected in some sense, and you need to put security systems around them. And security systems, I have a heuristics. If a security system doesn't include cryptography, but the underlying system it protects is complex enough, something is wrong. Okay, so I will cover some points of interest. It's not an exhaustive. Even myself, I know other points of interest, and I will try to convince you that actually AI can touch many, or not many, but a few areas of cryptographic research. And this will be for the talk is research oriented, not industry oriented. And let me start with the introduction. So, of course, in the longer talk, I ask the audience, what is the first touching point of AI and cryptography? And some people guess. The first thing to notice is Alan Turing, who worked in both. Worked in AI in the sense of, talked about machine intelligence in the sense of the Turing test, which is very pragmatic, was very pragmatic for its time to define what does it mean for a system to be intelligent. And during World War II, worked on breaking the German enigma and contributed to the war effort. So it's certainly the first touching point of the two fields. And here I talk a little bit about the AI evolution. And of course, AI formally started in the 50s when the name AI was coined by John McCarthy as the science and engineering of making intelligent systems, especially intelligent computer programs. That was the first definition. Notice that it defines artificial intelligence by using the word intelligence of systems. I think it's on purpose. Because narrow definition when you start a field is not healthy. On the other hand, if you define it broadly, it's fine. And of course, the areas of AI are reviewed on this slide. And let me note that the AI was having an AI spring and the general problem solvers after it was defined. Then there was an AI winter when people started having the hope that the general problem solver will work. Then there was again an AI spring with the 5th generation computing project in Japan, and everybody was high about it. And then again, it became a winter, and now it's a spring again. So when I tell people, they ask me about my opinion, I said, look, AI went like this, up and down and up and down. I was always here. When people were hyping, I was, be careful. When they were overly critical, I said, be careful. Anyway, modern cryptography is also something that started in the 70s and have been progressing so far. Almost every decade there was an addition to the field and advancement. And now we have a challenge. It's obviously AI is going to influence human life, what humans are doing, at least helping them doing it better. That's just at least the state that I see now. And we need to deal with the fact that a lot of what computing is going to do is going to be AI. So we have to start looking from a research point of view, where is the things that cryptographic research can help. So when I started, about 2 years ago, I started to think about, you have to look at AI, and then I looked at the Russell and Novick book on artificial intelligence, modern approach. I said, modern approach, let me see what's there. And then I was reminded that in the mid-80s, I was also working in AI. I had 2 papers on search that I forgot about, a heuristic search. It's section 3 in the book, or chapter 3. And I found those papers. So interesting. I was a student then, and I wanted to look at every field and study it in some depth. The best way to study something with some minimum depth is to do research in the field. And 2 papers came out of that study, modest study. But I'm not making this any point, it's just a comment. The second touching point of the field is that a big notion of proofs in cryptography are based on the notions of indistinguishability. It's a security notion, but if you look at it deeply, philosophically, it is modeled after the Turing tests. Like your system, and you have a simulation that doesn't use the secret key, and you want to say that they look similar to the attacker, so therefore it cannot attack the system and find the key because it looks to him like the system without the key. Okay, so these are the initial 2 points, and now touching point number 3 is, I call it crypto computing in general, but it includes fully homomorphic encryption, confidential computing, and so on. People are talking about processing data either at any stage of AI in a way that you don't get access to the data, and these are the cryptographic tools, multi-party computation, and so on, that allow us to process the data without accessing the data. Think about it, working on ciphertext and producing the results, or working in a part of the architecture in which we don't have the access to the data. Okay, the point number 4, and you know, the long talk, I talk about the points in some length. Here it feels like I'm repeating talking points, but this is an election year, so talking points, yeah. So touching point 4 is the idea that for security you want to keep the model safe sometime. Not for security, for economic reason. And I think the previous panel missed an economist to argue open versus open source versus not open source. But sometimes you want to hide it, and people were talking about already in many years ago, but in recent years, about just simply using the model in a black box fashion, you get to learn the model. There were papers about it, like last Eurocrypt, this year, and before. And this borrows a lot from the probing of cryptographic devices. You ask the device to sign something for you, if it's a digital signature, or decrypt something for you, and then just by probing, you start learning the key. So this is an interesting area. Point number 5. AI can help in generating mathematical proof. Cryptographic systems are complex, and getting the proof right sometimes take a few iterations. And AI, if it gets better in augmenting human ability to prove mathematical theorems about dynamic computing systems, it can help cryptographers. And again, I'm talking just about augmenting. I'm not thinking that AI next week AI will replace all mathematicians upon Earth. No, but helping in making sure that the proof is sound and things like this is a good point. Point number 6 is distributed learning and federated learning, and there are two interesting points. 2016 and 18, I left Google, I went to Snapchat, and then we had a distributed data collection in general to do it, and we developed a system of doing it just to solve a problem. So sometimes these distributed things that people are talking here are naturally occurring when the data sources are distributed. Meanwhile, the folks that I'm with now in Google invented federated learning as a way to collect the data and make sure that privacy is kept. Point number 7 is side channel attacks and AI analysis, preliminary statistical studies that were introduced in 2009 in a paper that I co-authored. People are now using AI analysis in order to try to understand the interaction between keys and the physical data that comes out of the architecture, and then use it to break cryptographic system implementation hardware. Number 8 is why do it only for side channel? Do it also for cryptanalysis. So people started to look at it. It's not so easy. It's not automatic, because cryptanalysis is in many ways an art. AI is an art, and now you combine two arts. It's, art is not as easy as scientists tend to think. 9, and this is something I worked on, is people are doing robust AI with attacks on inputs. So, and then people from the other side say, oh, we'll use cryptographic method to protect. So I started to work on assume your data is protected by digital signature, and then most of the attacks that modify data and add data cannot happen, but you can still drop data. Even a signed item can be dropped. And we exhibited attacks just based on missing of data or targeting some data to be missed. Point 10 is deep fake. We are in the world that AI will generate very convincing data, and we have to deal with it. This is a point of question. I have more questions than answers here. I don't think people have good answers. Point 11, what can cryptographic methods and methodology and the theory of cryptography that has been developed help in understanding and developing theory for AI? And there are initial works on it by, for example, in Fox 22, Foundation of Computing Science, a paper by Goldwasser et al. Try to show how to backdoor machine learning using formal cryptographic methods. So you see, it can be used for many. The cryptography can be used in many ways around AI. And I wanted to raise the touching point 12 is what are the societal impact and implication of having AI and cryptography working together. Cryptography in general got rid of the necessity of face-to-face transaction. That were necessary before. AI is going to take a lot of the processing automated. What does it mean for humans? What does it mean for labor? What does it mean to society in general? We have to think about this. How life, work, society is going to evolve. And now I will conclude. And I say that even though it was just a listing of points, that there are many ways that cryptography and AI touch upon each other. I just chose some points to demonstrate it, a variety of points to cover a few areas. It's very, the field, modern AI and modern cryptography and cryptocurrency are very young fields, and it's fascinating to look at it. And I think there will be interactions, even points that I didn't touch and even points that I didn't think about. I don't pretend to know it all. I know very little. So thank you very much.
Thank you, Modi. I'd like to welcome up our next speaker, Chester Chen from NVIDIA, who is a senior manager there working on, who will talk about their federated learning with confidential computing. Chester?
Okay. All right. My name is Chester Chen. I'm the senior product manager and engineering manager for NVIDIA Federal Learning Teams, the product called NVIDIA. So I'm going to talk about decentralized computational AI, in particular computational federal learning, essentially federal learning with computational computing, with the NVIDIA's FLAIR. So, or I should look here. Okay, so I assume that most of you already know what is the federal learning. So I don't need to talk about why federal learning, how it works, and all that stuff. So I'm going to straight get into the first part is what about the FLAIR, NVIDIA FLAIR? Give a quick overview of this framework, and then we'll talk about the use cases of the computational computing and their processes that probably touch on the thread models, and then we'll talk about the tech stack. What is constructed of the federal computational computing tech stack, and finally talk about how the NVIDIA FLAIR with the computational development, so what the current state. So that's kind of the talk. So get right in FLAIR. So NVIDIA FLAIR is an open source project. So it's an Apache 2 license. So literally you can use any way you want it. So it has been developed for a couple of years. The difference from the many other frameworks in the FLAIR is the first start is designed for production. So it's not just for research, it's tailored for research, but also designed for production. So we have all the designs very geared if you develop something for simulations, for research, and you immediately can transfer for production. So that's about the key part. It's a cross-internet, in which try to emphasize that federal learning, of course, is not just for internal use for cross-internet, but we emphasize that because the internet across the board, across the countries, there's a lot of network interruptions. So we have taken that account, and there's a many production use case, in that. So we have a lot of productivity tools, and for including in high availabilities, multitasking. So basically, you can submitting multiple federal learning jobs concurrently, running a different job altogether. And also we have the easy to use. So basically, one particular issue is federal learning sounds great. So I have my centralized machine learning code. I have either traditional machine learning, XGBoost, or scikit-learn, all that stuff, and also in the deep learning, transformer models and graph models. How do I convert it to federal learning? So with our latest API, literally you can change 3 or 4 lines of code, use traditional machine learning, become a federal learning code. So that would make it really easy. And the other part is that we talk about federated LLM, large language model training. So we had a ton of examples of how to do, supervised fine tuning, problem efficiency tuning, prompt tuning, all that stuff. But in particular, we also have this we call the LLM streaming. In a sense, like if you do this, send the data across internet, basically using, say, for example, gRPC as a protocol, and usually has a limitation how much object you can transfer over the wire. So basically like less than 2 gig. But if you have A100 with 80 gigs in the memory, how do you transfer over there? So you could say, hey, I can upload to another file and share the other one. That usually doesn't work for the real federated cases. So basically, we developed the streaming technology, basically chunk the model into small chunks and then send it over the wire and then reassemble on the other side. So another thing we want to emphasize in the NVIDIA Flare is basically framework agnostic. You can use a PyTorch, Lightning, TensorFlow, XGBoost, any way you want it. It's model agnostic. It doesn't matter. It's graph models, K-means and all the other stuff. It's a domain agnostic. The Flare has been used for multiple industries, whether it's medical imaging, pathologies, financials, fraud detections. Totally agnostic to the domains. And of course, it's a task agnostic. Means that this is not only for learning. You can use for any other jobs. Like for example, you can do ETLs, you can do statistics analysis. So and then in terms of privacy protections, we have several technologies being put there for having examples using differential privacies, homomorphic encryptions. Of course, we have using for private set intersections and also computational computing. So for computational computing, so we try to develop the end-to-end, not just to say, hey, here we have computational computing, but it's end-to-end flow, how to put them together. We'll touch more on this point. The framework itself is layered, and I have a next slide on that. It's basically pluggable. And then we have a secure provisioning. So we also have, forgot to mention that, we also have integrations, going to be announced integration with another open source framework, and our CEOs right there, Flower CEO. So we have Flower integrations, right, come out next release. So in terms of architectures, as I said, so this is building on layers. So the bottom layer is a network communication messaging layer. So it's kind of independent from the top layers. So essentially, underneath, we have multiple protocols already built. For example, we have a gRPC by default, but you can use a TCP if you want, if you just locally. You can use HTTP, WebSockets, and other companies have building other drivers for their needs. For example, Microsoft decided using Redis. You can plug in a new driver, the up layer doesn't change. A layer on top of that, we call it federated compute. In a sense, it's a federal learning, just a special application of this framework. So we can, as I mentioned earlier, you can do any kind of a task because you have this, we call a controller, controls what the logic you want to be, and the executor on the client side is basically carry out a task. So let me see what else. Built on top of that, we have these federating workflows, and whether you're using scatter and gather, you want cyclic transfers, you have different type of federating workflow built on top of that. We also even build a swarm learning, like a site to client type of peer-to-peer type of machine learning workflows. There's a lot of building algorithms like a Fed average and Fed ops, and many examples that we have been built together. The framework offer a lot of APIs I mentioned before on the client training side, literally 3 or 4 lines of code changes. But if you want to say, hey, I'm a researcher, I want to do additional federal learning algorithm, just not the building the control side. You can, in our latest release, you can easily change that, just a very simple Python code changes. Let's see. We have, of course, I have a lot of production tools. So it basically means that, okay, so do a simulations on my local machine, that's fine. But what if I want to simulate a lot of clients on my local, and the next one I go to the cloud? So with our cloud deployments, like literally one simple line command, you can launch it on the AWS or Azure with the client servers all set it up, and the resources, the provisions are already done for you. So there's quite a bit of, if you want to say, hey, what if I want to distribute my kit to the other side so he can connect to me? How to do that? So we have something called a dashboard. You can basically go there, down to your startup kits, and so people can set it up. So in a summary, so really build for customization, build for federal compute, for productivity, and also is totally customizable. So we have many customers doing that, and so I don't want to spend too much time here. So next, let's talk about computational computing. So especially computational computing with federal learning. So what's the use cases and how their specialty comes in with the federal learning. So a lot of people have heard of the computational computing. So there's many use cases, but there's a lot of cases actually particular with multi-party computing. So like, for example, for government, you have a multi-agency get together, how to deal with the data come together without have to share each other. Healthcare, of course, patients, hospitals, financial services, multi-bank payments, transactions, manufacturers, quality controls or in supply chains, enterprise, if you have HR with multi countries, how to share that sensitive data. Of course, for any industries, you have this so-called clean room. So essentially, the multiple data have put together, but nobody's supposed to knows the other ones. You can use the computational computing for all these cases. So now for federal learning, so of course, there's something particular. So federal learning, you have a multi-party come together, train a model. So the requirements, of course, comes in, hey, the data, we don't move the data, but at the same time, you not leak the PII information, right? So you're not supposed to leak my proprietary business data somehow, even you send a model. But if we do a collaborative training, for example, if I do large language model training, I have a pre-trained model. I don't want my model, which I spend a lot of GPU hours to train, simply got copied from the other side. Well, I'm leveraging the fine tuning, find the data from the other side. So how this computational computing can help you? Oh, shoot, only 5 minutes? Okay, I'll be really fast. So basically, we can use multiple cases. One is basically building something called explicit trust. Essentially, how do I even trust the other guy who's sending the model? The next one is secure aggregations. And then the other one basically means that you can make sure the models is secure aggregated with alternative means. Like, for example, before you're using differential privacies, now you can use something else with computational computing. On the training side, so you can use computational containers and all that stuff. But I'm going to really quick. So there's a certain process in order to get this thing going. So there's computational computing comes with something called attestation. Basically verify whether the certain machines are trustworthy or not. These are multiple steps in the federal learning side. So you have to do different type of trust. One is I'm in the trust environment myself. How do I trust the other guys? Is also trustworthy. There's a cross verification. So there's multiple policies. What are the policy I set for myself and on the other guys? And the other part is what are you protecting? There's a code. There's models, there's data, the data, the input data, which is probably you already did on REST, and then you put it in. But also there's output directories. These are different volumes you can protect. And then the other piece is if I lock down my confidential trust execution environment, so how do I get my code there? So how do I do this key release management? There's a key broker services. So, and there's what's the steps to get them up. So the tech stack, I'm going to skip this, and I'm just briefly talk about this. So these are the tech stack layers. So essentially on the bottoms, you have these GPUs and the CPU technologies hardware enabled. And then you have the certain operating system to enable, to leverage these hardware. And then the next level is the green ones, the 3 stacks, the virtualizations, and which is what kind of a computational container, computational execution environments you put it there, and then what the test station I mentioned there, and then what the key broker services. There's a particular 2 type of computational pieces, 2 kind, but it actually there's more. But briefly say, hey, one is called a computational VM. It's a VM, you can put the TE around it. The other one called a computational containers. And then there's other alternative, like for example, Google has a confidential space, Azure has a confidential Azure container. So there's a different dialects of the different parts, and there's a lot of test stations. NVIDIA has remote test stations, and Intel has Intel Trust Authority, and Microsoft has MAA. So there's a bunch of test station layers on the each tech layer. So Flare, what Flare have done is basically we're trying to get this complete end-to-end. The first part is we want to recognize this type of computational computing compared to 5-6 years ago. There's a slightly different. So there's something called a lift and shift. Essentially, basically, what you build in the federal learning without CC, you can literally take it over, put it inside this trust execution environment, no change. So that's a very great features in a lot of stuff. Before you have to special tailored for different algorithms. You don't need to do that anymore. So and for Flare, the first part is the building experience trust. We have integrated with pretty much every attestation frameworks and go through the different cycles of test trust. I'm going to not repeat. We have done a multiple different type of development for secure aggregation. For example, we have these are hybrid deployments. This is the stuff we demoed on the CC Summit, with some in cloud, some on-prem, and then secure aggregation. On the secure aggregation part, I want to say a few words. In this particular demo, we're using Azure Confidential Container, which is a container running on ACI, Azure Container Instance. It means that once you start it, nobody can access HTN. So in other words, if you want to reverse engineer the model, try to get the personal information, you can't, because you couldn't access whoever launched that container couldn't access themselves. So that way, it's alternative to, like, for example, homomorphic encryption or differentiated privacy, in this case, to fully protect you. There's another piece. Let me show it. Oh, we may say one more words. So the other part is federal learning mainly for targeting the data on-prem, right? So it's not on cloud. Cloud is interesting, but really the majority of the private data is on-prem. So there's another project coming, the cloud native CNCF community called COCO, which is a confidential container, so short name COCO. So that is a Kubernetes container, a confidential container running on Kubernetes. So that way they can deploy it on bare metals with these broker services, they call it trustees. So that's something we're currently working on very hard, and then they are kind of collaborating with them, pushing them, essentially putting the edge, putting the envelope, and just try to get all the functionalities in place. So this is one last slide. So we want to kind of pay attention to this two events. We have September 18 called NV Flare Day 2024 event, which is going to be event talking by at least a dozen of industry speakers, talking from drug discovery, medical imaging, financial services, the federated reg, for example, if you're talking about the reg application, this is the federal reg. So and also for self-driving cars, all using NV Flare to demonstrate it. So we have like the full packed half-day online course. The second one is we're going to announce this NVIDIA Academia grant programs, which is using with Flare to do a research. And I think NVIDIA have you GPU hours or something. The exact topic will be announced in fall. I think if the public link is come out maybe in this month, but the exact topic is in fall. So I don't know exact date, but I think you need to pay attention to these two events. Thank you very much.
Thank you, Chester from NVIDIA. Next, I'd like to welcome up Professor Dawn Song, who is one of our faculty members at the College of Engineering in the EECS department. And she is also the co-faculty director of our Center for Responsible Decentralized Intelligence at UC Berkeley. So please join me in welcoming Professor Dawn Song.
Okay, great. Yeah, thank you. Yes, my name is Dawn Song. I'm a professor at UC Berkeley and co-director of the Center Berkeley RDI. So today I will talk about building an open, responsible AI economy. So as we all have seen and experienced this exponential growth in large language models and modern AI, and these new technologies empower rich new capabilities, and a lot of these development has made a rapid advancement on AI model performance. Many of these AI models have reached the human level performance on many of the benchmarks. And we foresee a really exciting AI era where we'll have a lot of these agents, including, for example, personal agent assistants that actually is going to intermediate most communications between individuals and external worlds. And also we'll have a lot of diverse agents for solving different tasks. And in the future, we also foresee we'll have decentralized autonomous agents that will interact and act in a decentralized manner. So with this exciting AI era, there also comes many different challenges. So in particular, in this talk, I will focus on 3 key challenges. First is how can we ensure building a responsible, safe AI? And second, how can we ensure to build a user-controlled open architecture and protocol for innovation? And also third, how can we ensure responsible, fair data use and value attribution? So first, as we deploy AI, it's really important to ensure trustworthy and safe AI. And there are many different aspects for this in terms of the different challenges and perspectives, including, for example, hallucination, robustness, privacy, fairness, toxicity, and so on. So in the interest of time, I'll just focus on one example challenge as for trustworthy AI as we deploy AI systems, in particular with adversarial attacks on these AI systems. So my group has been among the earliest to working the area of adversarial robustness in AI, and our work and others have shown that today's AI systems, they all suffer from these adversarial attacks. For example, attackers can simply just change for example, manipulate the inputs to the model, sometimes with even humanly imperceptible changes to these inputs, and then cause the model to misbehave. So for example, when we started working in the area, there are only a very small number of papers each year, but by now, actually, there are thousands of papers in this space each year. And also, we had the rare honor and pleasure that some of the artifacts from our earlier research adversarial examples in the real world, for example, on these stop signs, have now become part of the permanent collection at Science Museum of London. For computer science researchers, this is actually a very rare honor and pleasure. And also now, today, as we utilize large language models, we need to make them safety aligned, and adversarial attacks continue to cause huge issues on the safety aligned large language models. So one of our recent work called Decoding Trust has developed the first comprehensive evaluation framework for trustworthiness of large language models, where we develop new algorithms and frameworks to evaluate many different perspectives on trustworthiness for these large language models. And the paper has won the Best Paper Awards at NeurIPS last December. And from our work, we have shown that today's large language models can still be easily attacked and suffer from many different types of risks. Using our evaluation framework. So on one hand, we see that adversarial attacks are really effective, and also for the community has been really productive and creative in developing many different types of attacks on these large language models. As I have shown, now we have thousands of papers per year on this topic. But however, on the other hand, the progress on developing adversarial defenses has been extremely slow. For example, so today we do not have effective general defenses against these adversarial attacks. So as this gap continues to widen, where we make rapid progress on adversarial attacks, but the defense against adversarial attacks has almost made no progress. This poses huge challenges for AI safety. So current AI alignment mechanisms are easily evaded by adversarial attacks, as I just illustrated, and any effective AI safety mechanisms need to be resilient against adversarial attacks. So this poses a huge challenge for AI safety, where AI safety essentially needs to address adversarial robustness first. And as I demonstrated already, where today the community has made almost no progress, and we don't have good defenses against these adversarial defenses. I won't have time to go into details in terms of what are the next steps that we can take on these defenses. So this is a recent initiative that we launched together with other researchers such as Yoshua Banjo, who's the Turing Award winner and pioneer in deep learning, on how we can develop better AI safety mechanisms with this initiative called the Quantitative AI Safety Initiative. So overall, AI safety will be one of the biggest challenges in AI deployment. And I'm also part of an international dialogue, efforts on international dialogue on AI safety, where a small group of leading researchers and scholars in AI and AI safety, we actually talk with governments around the globe to raise awareness on AI safety and facilitate international cooperation on AI safety. And one of our recent convening took place actually in earlier in the UK and then recently in China, where we proposed a number of red lines for AI safety, where AI model development should not occur. So that's the first challenge on how we can ensure building responsible safe AI. So due to due to issues of time, I won't have time to go into other aspects of responsible safe AI, including how can we mitigate misuse of AI and mitigating loss of control. So now let's move on to the second key challenge for the AI era, which is how can we enable user-controlled open architecture and protocol for innovation. So as many of us have seen, so with today's internet, while it provides great utility and productivity for society, but it's plagued with many issues. In particular, today's internet is platform-owned, and as a consequence, users lose control and have very little influence, and essentially users are actually the products, and creators are also now being fairly compensated with their contribution. And overall, this closed platform hinders innovation. And these issues, if not addressed, will continue to worsen in the AI era, where, as we already see with the current developments in AI, again, it's largely controlled by centralized parties such as big tech. This offers very limited choices and control for users. So for example, in the future, if we don't, if nothing is changed, we even these personal assistants and so on, they will continue to be controlled by a big tech, which can pose challenges in terms of user control. And also today's closed platform lacks transparency and attribution, and also creates data silos where a lot of valuable data are also not being utilized for contributing to build better AI models. And as a consequence, essentially, with the current developments, we are the end result is feudal AI, where instead we want to have democratic AI. So how can we address these challenges? So the vision is that we need to build an open platform of AI assets and enable user and contributor control with decentralized trust. So one key reason that causes the centralized platform today is that the application services, they need trust, and this trust leads to today's centralized platform. However, with the recent technology advancement, essentially we can utilize new technologies to reduce the need of centralized trust, and instead we can have decentralized trust. So these recent technology advancements includes confidential compute and distributed ledger. So now I'm going to briefly talk about how these recent technology advancements can really help reduce the need for centralized trust and hence enable building this open platform of AI assets. So I wanted to, so Chet briefly mentioned about the NVIDIA confidential compute. So here I wanted to also just share a little bit of some background story. So at Berkeley, we have been developing the first end-to-end open source secure enclave called the Keystone, based on RISC-V. Started back in 2018, 2019. So back then, we were also hoping that, so the Keystone is secure enclave confidential compute on CPUs, but back then, already we foresee that more and more of the AI workloads will need to happen on GPU. We're also hoping that the future GPU developments can actually have secure enclaves, confidential compute capabilities. So actually, back in 2018, the security architect of NVIDIA actually came visit Berkeley, where we had in-depth discussions about how to how it's not only feasible but also not too expensive to add confidential compute secure enclave capability to the GPU. So we are also I'm really happy to see that now 5-6 years later, now finally we have this confidential compute secure enclave capability on NVIDIA's H100 GPU. And also, so back in 2019, we actually organized the first open source secure enclave workshop at UC Berkeley. And as the opening remark for the workshop, I gave a prediction. Back then, that was 5 years ago. The prediction was that in 10 years, most chips will have secure enclave capabilities. So now we have 5 more years to go. So I'm holding out for my bet to be true. And I think it's a really exciting time for confidential compute. So with this type of new capabilities in confidential compute, of course, it can enable a lot of exciting new applications and services. So here is just one very simple example that my group has done that you can actually try out on the website later. So we can, so for example, right now, when you use, for example, ChatGPT and so on, the data all goes to OpenAI, and you have to rely on OpenAI to honor terms of service if you want to opt out, not to have them use your data to further train their models and so on. But however, with confidential compute here, we can simply enable a confidential chat. Essentially, in this case, the model will be the model, and actually the backend web server can run inside the secure enclave and the confidential compute environment using the latest GPU capabilities, and then now we actually have end-to-end secure services where users can securely talk with the LLM with all the data being kept in confidential. And also users can verify that this is the case. So that's just a very simple use case example that you can actually, again, try out on our website later. So what's more exciting is as we combine this confidential compute capability and distributed ledger, we can enable a new type of digital assets that we call AI assets. So these include, for example, AI assets based on data and AI models. And they are controlled by fine-grained, they can be controlled by fine-grained policies. So essentially, we have these data assets that are encapsulated and in an encrypted form with policies, fine-grained policies attached to it, and together asset plus policy together is called a manifest. And these manifests are signed and integrity protected contracts that can provide fine-grained control of asset use. And these asset rights are enforced using policy and payment engine to using confidential compute technology and digital ledger. And with this combined technology, we can enable operations, a wide spectrum of operations on digital assets. We can provide the full tracking of provenance and usage of these digital assets, and we can enable decentralized access control and policy compliant computing on these assets. And this will enforce fine-grained rights and policies defined by data contributors and model developers, and enable privacy-preserving model training and inference. And also, without this tracking and policy enforcement, it then can also enable disbursements of payments to data contributors and model developers based on the terms defined in the policy and also values contributed to these assets. So with this technology, with the AI assets and the confidential compute and distributed ledger technologies, we can further enable the reduction of friction and trust needed for collaborative learning. So Tristan mentioned about federated learning in the earlier talk, but here we can also actually go one step even further. So, using this technology, we can actually enable new a next generation of playgrounds and sandbox for collaborative and collective learning. So in this case, for example, model developers can try out data provided by data contributors in the playground. If the data doesn't help, then the playground can simply erase everything. And in this case, the data contributors don't lose anything. And if it helps, then the final trained model can be packaged as a model asset. And this asset can be governed by usage policies and value attribution and sharing terms that's specified by data contributors and model developers. Using this approach, also it will make it much easier for model developers and of different models and different data contributors to collaborate to build better AI models and services. And further, we hope that this technology can enable much larger scale of collaborative and collective learning scale to many decentralized entities with both rights enforced and also value attribution and distribution enforced as well. Here is a high-level overview of the technical architecture for this open platform for AI assets. This open platform is designed to have to be open, enable interoperability, and enable wide integration with a lot of different stakeholders and different subsystems operated by different parties. So, for example, with this open platform, we can provide aggregated data marketplaces where data contributors provide their data assets, including these encrypted data with policies attached to them, and also enable aggregated AI model marketplaces that enables, again, different model assets with usage policies and terms associated with them. And these developers can utilize the data assets and also model assets in these marketplaces to further train and fine-tune models based on different base models. And this computation can also happen on a decentralized confidential compute fabric, which is based on a computation based on the compute marketplace that's decentralized as well, that connects to essentially globally widely distributed and decentralized compute facilities. And the trained models can then be utilized by different AI service developers to provide diverse AI services. And these AI services can also be aggregated as AI service marketplaces. And these AI services are policy enabled. And then users can use these AI policies where these policies are being enforced, again, using the underlying confidential compute decentralized compute fabric. So with this decentralized AI services running on this open platform for decentralized this AI assets, we can also, here is an example illustrating the flow of value which are being enforced by the terms and service and policies specified and attached with these different AI assets. So, for example, as users use the AI services, these AI services will accrue value. And then, given that this whole platform tracks how essentially tracks how the usage of these AI services, and also can enforce the terms and policies, it can then disseminate, distribute the value according to the specified policies and terms to the model developers and to data contributors and to the different stakeholders and also to the compute providers as well. To enable this open platform for AI assets, we need a number of supporting technologies, some of which I have already mentioned, such as confidential and distributed compute. In addition, we also need decentralized identity, decentralized access control and secret management, decentralized policy compliant computing, and also data valuation and value contribution, and also game theory and incentive design, and also agents, and also decentralized agents framework, and so on. So, so my group and also other researchers have done a lot of work in all these different domains of supporting technologies, including some of our earlier work on data sovereignty that actually defines and explores the space of decentralized access control and decentralized policy compliant computing. So with this, another open question is how then, given all these AI assets, how do we actually ensure responsible and fair data use and value attribution right, in this case? So as we all know, data is the lifeblood of AI. Unfortunately, today, there are a number of issues with data contribution. So first, there are lots of data is sitting in data silos. Valuable data is not being utilized. Second, creators and data contributors are not fairly compensated for their data contribution. So how can we enable better incentive? How can we better incentivize data contribution and fairly distribute value? So with my my group has been was among the first to actually explore this question, and in particular, we developed the first rigorous framework on data valuation for machine learning models, utilizing a framework first developed by Shapley, called Shapley Value. And Shapley is a Nobel laureate on economics. And the high-level idea of this Shapley value-based data valuation is that we essentially model each data contributor as a player in a collisional game. And the value contributed by the data contributor is based on the marginal contribution of the data contributed by the contributor based on the utility of the model. And actually, so Professor Ruoxi Jia in the afternoon is going to talk more on this topic, who has been a long time collaborator. So now I have discussed these 3 key challenges for the open era. And to summarize, when we look into the future, so first, nation states leaders have mentioned like whoever controls and leads in AI will rule the world. And unfortunately, let's look at what is the status quo today. So this actually, so this small part is actually from a presentation that I gave in 2018, 6 years ago. So that was actually the last, the AI wave. And so when we look at the status quo today, is that we have this big attack where in this closed platform, where each big tech actually is building essentially profiles of each individual user in the walled garden, and using their services to essentially provide services to end users. And they can provide driving directions, career advice, or even life plans. So the question is, in this case, who will be running our lives in the future? So with the current paradigm, essentially we'll be having these big tech closed platform that who will essentially be running our lives, who has the goal of maximizing value. So is there a different future? So we hope that in the future, we can have intelligent agent, personal assistants that's actually under user control, that will be interacting with users to provide these services to users, and at the same time to interface and interact with external services provided by third parties. So the important difference here is that instead of maximizing company values and revenues, these personal assistants that's under user control will actually be maximizing user value. So this is the aspiration that I talked about back in 2018. And I think with today's AI advancement and development, this issue is only more daring. So again, to summarize, the problem with today's platform-centric approach is that a closed platform today the whole society is running on this closed platform with full stack locking and walled garden, and the centralized platform decides on value attribution and distribution, and users have very little control and privacy protection, and have very little choices and bargaining power. So in the future, we hope to build what I call an open, responsible AI economy. In this open, responsible AI economy, we can, again, as I mentioned, have these personal assistants that actually is under user control, that they can provide services to the user with the goal of maximizing user value while interacting with other agents provided by third parties. And there are three key pillars for this open, responsible AI economy. First, openness to provide users with choices, transparency, provide community governance, and enable accelerated open innovation. The second pillar is responsibility to ensure a safe, trustworthy, and responsible AI. And the third one is to enable a democratized AI economy to reduce friction, disintermediate, and enable value attribution based on contribution. And there are a number of foundational components to the three pillars, enabling where we can, with frictionless data contribution, where everyone can contribute to all of their data and to break down data silos and give AI back to the people, and enable sharing of computational resources, where we can break down computational silos to allow anyone to contribute to developing cutting-edge AI, and enable fine-grained control for developers and communities, where, for example, model developers can enable fine-grained controls on their models, enabling novel business models, and also not just having this binary choices of whether to keep the model open or closed, but actually to enable more fine-grained usage policies, and enable transparency, verifiability, and auditability to provide the observability needed to ensure safety and equitable use of AI assets. And also this can support for assessing and comparing AI models, and to enable interoperability and composability, to enable free remixing of different AI services, to like what open source does for software, and finally to enable community governance and safety. So with this open platform, it can also provide a key contribution to public good for AI safety. We can have decentralization and community governance to facilitate a bottom-up consensus on what safety properties are most needed. And also this open platform can dedicate a huge percentage of its, for example, collective proceeds for AI safety research and technology development, to enable AI safety development as a public good. And also the open AI economy can disincentivize harmful models and incentivize the creation of technologies to mitigate, again, the various AI risks. So with this, with these technologies, we hope that this open, responsible AI economy can enable a truly exciting and responsible future for society, where we can have AI agents to help automate tasks and give humans more time to be human, and the value produced by this AI economy can help lift the standard of living and wellness for everyone. And we can enable safe applications of AI technologies to accelerate scientific discovery and leading to a post-scarcity society. So with that, I hope that everyone here can join this journey and efforts to build an open, responsible AI economy. So with that, so first, as I talk about agents, as I mentioned earlier, so this fall, Berkeley will be offering a new class on large language model agents, and the class will also be available online to students online. So you can check out more details here. And also for this efforts on building an open, responsible AI economy, you can sign up to a mailing list here to stay tuned for further progress. So with that, thanks everyone.
Next, we'd like to, just before lunch, have our second panel of the morning. So we'll have our speakers, Chester Chen of NVIDIA, Modi Young, and Dawn take the stage. The panel will be moderated by Professor Jia of Virginia Tech. So please welcome our panelists for the second panel.
Hello, everyone. It's my great honor to moderate this pre-launch panel. The theme of this panel is about confidential computing, decentralized AI, and crypto. So from left to right, we have Dr. Moti Young, Professor Dawn Song, and Dr. Chester Chen. So we have been hearing a lot about decentralized AI, a lot of amazing touch points with confidential computing and crypto. So my first question will be, how do you envision what are some kind of most exciting innovative applications that would emerge from the convergence of these technologies, confidential computing, crypto, and decentralized AI? Could each of you share some perspectives on this convergence and applications?
Okay, I will start and I'll be safe. I have a few examples, but I'll be a bit safe. And I will say the major application is that the following. Sometimes you wake up in the morning, you want to know something, you consult this decentralized AI about it, and you do something. And then you think about another idea, you probe it, and it gives you an advice. So it's an intelligent assistant for, the safe one is for humans. They give them benign advice. Now you can see that based on this, you can build much more. Organizations with certain goals can ask, national security issues, can ask geopolitical issues, and many, many other things which require much more safety and much more accuracy than telling me eat tomato or potato. Thank you.
Yeah, thanks for the question. So as I mentioned in my talk, I think with the convergence of these technologies, it can really enable this new open platform for these AI assets. And the hope is that it can really significantly reduce friction in building AI models and AI services, because now data contributors can contribute data without worried about losing control of their data, and can still can get a fair value attribution from their data. And different model developers and the data contributors, they can very easily get together. So today, a lot of these things essentially relies on offline, like individual contract negotiations, and still there's a lot of issues with the trust. What happens whether the model developer will misuse the data from the contributor and not providing the proper value back? All the different model developers and data contributors, it's difficult for them to come together to build better models and services. But with this platform, that can enable the establishment and enforcement of these AI assets, it can enable all these, as I mentioned, this collaborative and collective learning from even a large scale of different data contributors and model developers. So that the hope is that with all these technologies, we can build much better AI services, AI models, and ensuring the value to be properly attributed back to the different contributors and stakeholders, and also to enable interoperability so that each contributors can easily plug into this decentralized fabric and can participate in these different marketplaces that, as I mentioned, the data marketplace, the compute marketplace, the model marketplace, and AI service marketplaces, and so on. So really enable a thriving AI economy that helps accelerate innovation and providing value to all the different stakeholders.
Yeah, I have a follow-up question here, and then I will let Dr. Chester share your vision. So Dr. Song, you have shared this very exciting vision about open, responsible AI economy, which is quite exciting. So from what I understand, it sounds like kind of facilitate exchange of models, data, intelligence with built-in incentives. So along
the policy enforcement.
Yeah, so thanks for adding that. So along that line, there are already some existing efforts for building data marketplaces, model marketplaces, and even marketplaces for inference. So how do you see these existing efforts fit in your vision, and how your vision differ or build upon this existing?
Yeah, that's a great question. So so with this vision, essentially, it helps integrate with all these existing efforts. It actually provides, as I mentioned, this decentralized fabric that really enables all these. Currently, there's also isolated different data marketplaces and compute marketplaces and so on. But now this actually enables integration and aggregation of all these marketplaces and players all together contributes into this decentralized fabric for confidential compute and for enforcing these enabling these AI assets, and also it provides more principled way for this value attribution as well. So I think with this interoperability, we are really excited and hope to see this interconnection among all these different existing efforts and services.
Great. Dr. Chen, do you want to go ahead and share?
I want to say a few words about how the emergency, the computational computing and the federal learning. So, of course, the federal learning has been around for a while, and the computational computing technology is not new today. So it has been around for 10 years. But I think this year is different. So with a new H100 and all the training and the inference capabilities, all of a sudden we see the combined federal learning and the computational computing. A lot of our customers used to be hesitant using adopting federal learnings all come back. I've seen tons of them from financial services and healthcare, and actually because of confidential computing and the federal learning, the way you enable the people literally almost as good as you have a centralized data. So that leveraging a lot of private data, which previously they hesitated to allow us to do, now enable it. So I think that a lot of new excitements are coming from these combinations.
That's a great point. So for federated learning, you mentioned there is increasing adoption of federated learning, which has some privacy and security guarantees. So on the other hand, so we all know that data quality is very important for building powerful machine learning models. And a lot of data filtering and curation efforts relying on experts looking at the data, filtering out the bad data. So how do you envision we address data quality problems in this federated setting without looking at the data?
Right. So this comes, this seems like a conflict, and you have to look at the data. That means that you're assuming we need access to the raw data itself. But with the federated learning, there's other techniques so you can mitigate this. For example, you can look at the federated statistics on the different sites, and then you can look globally looking at data. And then you can also looking for the contributions of the model itself. Basically, you can estimate how much data contributing to that data to indirectly looking at the data qualities. So there are multiple ways to do that, and you can also look in the exploitabilities of the different aggregated ones. So there's many techniques. For example, at Federated, we also have a federated statistics to allow the looking at the histograms and the distributions of the different data sets. So there are multiple ways to do that.
Yeah, that's a great, very comprehensive answer. So next question is for maybe Dr. Moti or anyone want to chime in. So you briefly mentioned the connection between this decentralized AI and building safer models. We all know that like right now, AI safety is really getting a lot of attention. So like, of course, AI safety is a very broad notion. It can be like not outputting something that can be potentially misused or not outputting some private proprietary data. So I will leave it to you guys to interpret what's the most relevant way that you think is AI safety. So with that in mind, how do we envision like decentralization, confidential computing, and crypto, or their synergies to help solve our AI safety issues or even make it worse?
The short answer is we are all wrong. It's not going to be the way we envision it. It's going to be different. And just think about it. You are putting a huge resource there, public, everybody is going to use it. It's the internet again, and everybody think, oh, when they thought about the internet, they say, oh, we are going to combine and compute together and help each other. No, it turned out not to be a marketplace. It turned out to be a war place. It looks like more a field for criminals, for at the nation level step, at the individual level step. So we'll put the AI resources, then we'll have to use AI in order to design a good access control system. Who do you think should access? Whom do you think should not access? That's the second level. And once you do this, you have an enlarged system. So who can make the decision? You know, there are going to be layers of making decisions, and AI is going to surprise us, not in the way that people think, oh, it's going to make human obsolete. No, in many ways, humans are already not needed. And it's not in the way that we envision, because due to the economic value of the marketplace that you put, and suddenly it becomes a war zone. When it's a war zone, it's a different thing. You have to deal with it. And definitely everything that this panel is about cryptography, about decentralization, about confidential compute, and other security measures, they need to collaborate to get it right. But this "it" is not yet well defined.
Dr. Dunn, Chester, do you want to share something?
I'll pass to.
Okay, so I think so that's why, as I mentioned in this open responsible AI economy, one very important aspect, this responsible means that we want to ensure, we want to build responsible, safe AI, and also I think it's very interesting in the sense that that's why I talk about this as a public good. Is that for each individual player, maybe it's not their best incentive to focus on building safe AI. So for example, today, the foundation model developers, even though they claim that AI safety is important, but oftentimes they are just rushing to build the most capable model, and not putting enough emphasis and resources to ensure building a safe model. So as I mentioned in my talk, I do hope that this platform for open, responsible AI economy can really have community governance, and also with the community governance to really place a high priority for AI safety, since AI safety is important for the whole society. And also AI safety, a lot of the research is for public good, because we are ensuring the well-being of the whole society. And hence, I hope that with this open, responsible AI economy, that with community governance, we can really dedicate a significant percentage of the resources, for example, even in this decentralized compute, potentially a significant percentage of the compute resources and also other resources as, for example, proceeds from this platform can be dedicated for AI safety research and new development to ensure that collectively, as a whole society, we build responsible, safe AI. And also, I wanted to add that, as I mentioned, I do hope that we are together as a society building towards this future of open, responsible AI economy. And there are many research challenges, open questions. How do we get there? So in my talk, I listed just an example list of supporting technologies. And for each one, there is active research, but there are more open challenges, open research problems. So this is also essentially a call to action to the research community and also to practitioners more broadly, is how we can collectively develop better solutions to address these open challenges and research questions in the with the list of supporting technologies that I provided as a starting example, to then together build towards this open, responsible AI economy. And for people who are interested, please also fill in the form at this open, responsible AI economy website. We hope to actually build up more research efforts and research collaborations to collectively address these problems.
Yeah, so Dr. Dang has just shared some vision about some future research topics. I wonder if Dr. Chen or Dr. Moti want to chime in and talk about maybe what do you think is the next big breakthrough you envision maybe in next 5 or 10 years in the intersection of confidential computing, decentralized AI, and crypto? Yeah, that will be the last question.
I don't think I can see that far, but I do see the confidential computing and the federal learning play a critical roles, and there's a multiple directions, both in research and productions, that can leveraging this technology, and the adoption definitely is growing up, and for multi areas. In we see in energy, in biology, drug discovery, and banking, financial services, and definitely. So those are areas, and also there's areas because you're now distributed and you're and now with the confidential computing is more trustworthy, and not just say, oh, you and me have a contract now. I can explicitly say you have the requirements I want, and you are trustworthy, so I can deal with it. So with that kind of a trust, so all of a sudden, so you can leveraging many things. Even the large language models, you used to have buy a lot of GPUs. You probably could distribute it with the different resources to leveraging the parallel models and parallel data. And so I think there's a lot of excitement can make the things happen with the federal learning. Essentially, if you're thinking really far, is that probably the AI is decentralized. It will be decentralized.
Thank you.
Yes, it has to be decentralized because no individual organization has all the data and all the knowledge. Yes, I think it was about the future. Yes, so you need to develop AI. AI is both and develop AI. It's a combination of widths and bits. You need algorithm, you need widths, and you need hardware and software and bits, and there will be investments in this. And people, again, to my point, what people do now is they scare the general population. They say, oh, AI is going to be so bad and and so on and so forth, yada yada. And this is wrong because you have to develop AI to the fullest, On the other hand, you have to develop in parallel the measures for assuring of safety, of anti-abuse, and such things, and everything has to be covered. In the mid-90s, I came up with the idea of malicious cryptography. That cryptography is going to be used for what became ransomware, for abuses by government, and for about 15 years, I was the laughingstock of the field. I was the only one working on it, and then it became a real thing. So when there is resources, people are going to try to use them, but there are no courses for AI for criminals or AI for malicious people. But they will come and they will try to use it, and we have to develop this, and it has to be a different branch that does not hurt the development of the processing power and the processing progress and the data handling techniques of AI itself. And it has to, it simply has to be done in parallel to be useful and safe.
Useful and safe, that puts this panel a great end. Thank you again for our great panelists, and I hope you all guys enjoy your lunch.
Thank you.
Well, thank you, everyone. We'll resume at 1 o'clock with the afternoon session. Oh, and we're also having a demo at lunchtime of the WorldCoin orb. So if you'd like to see how that does the iris scanning, you can meet with the WorldCoin people out in the lobby area.